Welcome everybody. Welcome to How GE Deployed a Data Warehouse on AWS using Matillion ETL. So at this time, I'll go ahead and hand the call over to Brandon. Brandon, please go ahead.
Hey everyone, I'm Brandon Chavez. I'm a Solutions Architect with Amazon Web Services, and to start this webinar off real quickly, I'd like to talk to you a little bit about Amazon Redshift, which is the underlying data warehouse platform that GE was using via Matillion. And so let's talk a little bit about what Redshift is and what it actually provides as a platform. At a high level, Amazon Redshift is a service we've built to act as a fast, fully managed, and petabyte scale data warehouse. And this service really makes it simple and especially cost-effective to analyze all of your data using your existing business intelligence tools. So it's really optimized for data sets that range from maybe just a few hundred gigabytes to over a petabyte. But the real strength of Redshift here is that it costs less than $1,000 per terabyte per year, which is about a tenth of the cost of most traditional data warehousing solutions. So it's fast, it's cost-effective, and you can launch a cluster in just a few minutes, and you can also scale with the push of a button. So if we think about what Redshift works for in terms of companies, what verticals it works for, we think that Redshift can provide data warehousing functionality at a price and a performance point that really works for a variety of verticals and use cases. So if you're a traditional enterprise and you're running your own data warehouse, we think that Redshift can probably save you money and add flexibility. If you're a company that has big data, for example, Redshift can make it a lot easier to start a data warehouse and make your data available for analysis. And then finally, it can also serve as a base platform for a SaaS offering, for example, if you wanted to add analytic functionality to some of your applications. So Redshift's not only cost-effective, but easy to use. And we say easy to use, we say that because you can provision a cluster in as little as 15 minutes. And there's no upfront costs for using it. You pay hourly as you use it. And Redshift really manages a lot of the work that's needed to set up, operate, and scale a data warehouse. So from provisioning the infrastructure capacity to automating a lot of the ongoing administrative tasks, such as backups and patching that you would have to do with a data warehouse. And Redshift kind of takes a holistic view of monitoring your nodes and the drives in your cluster to help you recover from failures. So Redshift has been tremendously popular. We have a number of customers across industries and verticals that are using it. Maybe a good example here is NASDAQ Security. They ingest something like 5 billion rows a day. And that allows them to analyze trading orders and quotes and provide a lot of detail to their customers. And Yelp, for example, they're able to analyze 250 million mobile events a day and analyze the effectiveness of new ad campaigns. So a variety of different use cases for a variety of different customers across different industries. So let's talk about the architecture real quickly. So Redshift is a columnar, massively parallel data warehouse, which is designed to be run as a clustered system. So Redshift is built around basically industry standard SQL. So you can interface with it through like a Postgres endpoint, which allows you to extend Redshift to a number of different BI tools. You can interact with it via a SQL console or a number of different tools on the front end. But it has some functionality on the back end to manage very, very large data sets and really support high performance analysis and reporting of those data sets. Looking at the architecture here, the leader node is essentially what your SQL endpoint lives on. So that stores metadata about your cluster and about queries and helps coordinate query execution. The data lives on the compute nodes, and your queries are run in parallel across the compute nodes. And then the nodes communicate with each other over a 10 gigabit Ethernet connection. They can also communicate to S3 over that same connection. So there's a lot of speed amongst the cluster and also when reaching out to other AWS services. So if we had to highlight a few benefits of the Redshift architecture, number one is that it's very, very fast. So all the operations that you care about from a database management and performance perspective are all parallelized across the cluster. And hence they scale horizontally with the number of nodes in your cluster. So as I mentioned, the data is stored on these compute nodes, and the queries that you run are executed in parallel across all of the compute nodes. You can load data in parallel to your compute nodes from S3, DynamoDB, or Elastic MapReduce using a built-in copy command in the Redshift API. You can also back data up to S3 in parallel from your compute nodes, which is a great feature. And when we say columnar storage, we mean that columnar storage basically only fetches the columns in your database that are required for the specific query that you're running. And the result of this is that you effectively get data compression in the order of 2 to 4 times. So all this compression allows you to effectively use less I/O and get greater performance. We also do some interesting things like using large block sizes on the actual disks in the cluster help us fetch large amounts of data and load it into memory quickly. And Redshift also comes with your choice of a couple of different hardware platforms. So you can create a cluster either using dense storage nodes or dense compute nodes. And they kind of have different priorities on the ratio of CPU to memory to disk available. And you can kind of pick the right underlying nodes to support your use case and help keep your costs down. So here we can look at some of the pricing here for some of the nodes. Prices start at about 1,000 terabytes per year for the 2.8 XL reserved instance. And reserved instances provide about a 70% discount off the on-demand price. So when you look at the hourly price of a Redshift cluster, keep in mind that it's for a single Redshift node. And the annual cost per terabyte is if you ran that node nonstop for a whole year. Redshift also doesn't charge for the leader node. So your cost is actually determined by the amount of worker nodes actually running per hour. So if you look, our smallest SSD node lets you get started for about 25 cents per hour. Redshift is also fully managed, which is a lovely feature here because it helps offload a lot of the heavy lifting you would otherwise have to do yourself. So for example, backups are managed and they're continuous and incremental. There's multiple copies that are made within and outside the cluster and stored on S3. So there's redundancy to your backups. And you can also do things like streaming restores. So the restore can happen in the background while the cluster can be made available for reads and writes within minutes of initiating a restore operation. So that works whether the backup is a single terabyte or hundreds of terabytes. And then Redshift also monitors the health of a variety of components and failure conditions within an availability zone and recovers from them automatically. So for AZ or regional level disasters, a streaming restore feature, or the streaming restore feature, will help you get back to business relatively quickly here. And then of course, security is built into the platform. Redshift leverages a lot of the AWS security features you've probably come to know and love and use currently. So for example, you can deploy Redshift inside of your VPC, and you can lock down access to it via ACLs and security groups. You can also encrypt all of your data at rest. You can use SSL to encrypt your data in transit. And you can also check out a lot of the security compliance certifications that the Redshift platform has achieved, like SOC 1, SOC 2, SOC 3, and PCI DSS. And then finally, with Redshift, we innovate very, very quickly. We've added over 125 new features since launch. So that basically comes down to a release every 2 weeks. And a lot of these features are driven basically by customers telling us what they want in the platform. And so if you end up using Redshift and you realize there's something that you need there that doesn't exist currently, feel free to ask us. Reach out to us and let us know what your feature request is. And that really helps drive our roadmap. So do let us know. So finally, that brings me to Matillion. And Matillion is a data integration tool built specifically for use with Redshift. It has an ELT architecture that delivers really fast performance and near linear scalability, and it really helps you unlock the power of the Redshift platform. It brings an easy and intuitive user interface and a cloud-first paradigm and deep integration into AWS services. So Matillion can be used to help improve your developer productivity. It kind of reduces the ramp-up time for developers to get familiar with Redshift. And then you can also launch it via the AWS Marketplace, which means That setup is pretty straightforward. It's a button click in the marketplace. The billing is also very straightforward because the billing for the product is rolled into your AWS bill. And it's also very secure because it's deployed into your own VPC alongside your Redshift cluster, for example. So what I want to do now is pass it off to Ryan from GE to talk about why they chose Amazon Redshift and Matillion ETL to deliver their cloud data warehouse requirement and what benefits they obtain from taking this approach.
Hello, everyone. My name is Ryan Oates, and I'm an enterprise architect with GE Water. Hopefully, you are all familiar with GE as a company, but by way of a quick introduction, GE has spent the last 140 years focused on building equipment and providing services around that equipment to our customers, especially in the infrastructure areas like power generation, healthcare, transportation, and aviation. Lately, our attention has been focused on reinventing ourselves as a digital industrial company. With our Predix platform that we're building, we're helping our customers find new sources of productivity with a level of interconnection and analytics on machine data that hasn't really been seen before. So with that in mind, I wanted to set the stage for the project that we're discussing today and share some of the context and motivation that led up to it. In the midst of this pivot towards becoming a digital industrial, all aspects of GE are getting challenged to connect more data of all types. The demand is ever increasing and our reliance on the output of that work gets ever more critical. That's driven my business, GE Water, to aggressively pursue a cloud strategy, moving everything possible to the cloud. This has been powered by increasing our own capabilities, but also by forging strong partnerships with leaders like Amazon. GE's CIO has gone so far as to ask us to move 9,000 of our workloads to AWS. There are obvious cost advantages, but frankly, even bigger drivers are being able to be more agile and being able to try out new technology even faster. So our discussion today focuses on our business intelligence platform. GE Water actually already had a very successful BI platform based on some advanced technology. We have a self-service model with our users, and to give them the flexibility they need in analysis tools like Tableau, we've had to build a platform with very high compute capabilities. With that level of openness, the underlying data tier needs to be able to support, ambitious analysts getting creative with their join conditions, etc. So we're already on a bleeding edge in-mem columnar database with outstanding query performance. However, the reality is that database was also a bear for us to manage. And we were increasingly finding stability problems with it. It was single node. So as we pushed it to its performance limits, we found the stability started to erode a little bit. And as mentioned before, those performance limits were getting increasingly pushed in the quest to integrate with Predix and bring together more and more types of data. So the challenge for us was to maintain our performance levels and capabilities while improving on stability and scalability. And given our rapidly changing business, we needed to find ways to shorten our development cycle and empower our end users directly. With all that in mind, we started looking at a Redshift-based solution. Initial performance on dummy datasets looked really promising. It also ticked boxes for us in scalability and easy management. So we began really trying to splice our existing tool set into the cloud and replace our existing database with Redshift. At the source, we retained our CDC or Change Data Capture replication tool to pull information out of our SAP ERP. The biggest challenge there was working with that vendor to enhance their tool to do S3 uploads to Amazon's object store in the cloud instead of doing ODBC upserts directly against the database. On the reporting side, we retained our Tableau capability, our server, our stable of reports, so really no kind of user-facing change there. And then we loaded our data into the cloud, ingesting it into Redshift, and started connecting our legacy ETL tools. The immediate discovery there was that strategy just did not scale. We struggled mightily for a while to optimize a system that wasn't designed for cloud-scale data and cloud-scale databases, frankly, as we started to work with Redshift. The solution came to us from our Amazon SAs when they recommended one of their partners in Matillion. So Matillion gave us a couple of things right away. The first was no barrier to entry. Brandon talked briefly about the Amazon Marketplace. That let us get started playing with it immediately, which led us to the second benefit very quickly, in that our development team, who had obviously never seen Matillion before, was able to get to work almost immediately. The UI is very logical. If you've worked with some other tools in the industry, this is definitely a big factor in scaling up a brand new team as we were doing at GE. Finally, unlike the legacy tools that we tried to pull into the cloud, it got us back immediately to impressive performance. So Matillion is cloud native, and it's built specifically for Redshift. So all that great scalability Brandon was talking about, we were able to take advantage of and get all the horsepower that Redshift had to offer us. A few of the outcomes from this project can be summed up in a couple of numbers, and this has always been an easy one to explain to my boss. While we didn't mention it at the outset, we were quite happy to save almost half of our operating expense by migrating from our on-prem solution to doing this in the cloud on Redshift. Second, we were thrilled that we got to useful results out of the system just 6 months after the get-go when we started working on it. As an aside, I mean, this project kind of inspired our team and lit a fire under some of my other peers in GE Water IT and whet our appetite for the kind of agility that you can get out of a cloud platform like this. Finally, I always challenge my teams to find ways to fail fast and with minimal impact. And so being able to run a proof of concept pilot on Redshift with Matillion via the marketplace for under $100 certainly qualifies. In terms of outcomes, I think overall we got what we came for. The performance of the system is enabling the ambitious use cases that we continue to throw at it. We have simplified our operations significantly with much less infrastructure that my team has to run. Resiliency and stability have also been a welcome improvement over our existing system. We've succeeded in dramatically accelerating our development cycle, and Matillion's intuitive user interface has made our team much more productive. It's also showing us how to get better, more immediate feedback from our stakeholders. We'll see a demo in a minute, but really the Matillion interface has been a great tool for sitting down with stakeholders, finance people, sourcing people, and just literally showing them what you're building. Instead of trying to roll your own ETL documentation that rarely tells the whole story, just using the Matillion interface to very quickly tell a story about how we're taking their data and pulling the value out of it for them is very powerful. But certainly the best way to get an appreciation for that is to see a demo, and Matthew Scullion from Matillion is going to show us one right now.
Brian, thanks very much, and good morning, everyone. My name is Matthew Scullion from Matillion. I'm only slightly nervous about giving a demo to several hundred people all at the same time, so we'll see if any of that comes across. Now, both Brandon and Ryan have mentioned the AWS Marketplace, which is where I'm going to start our demonstration today. If you're not familiar with the Marketplace, it's AWS's offering to allow you to provision enterprise software in the same utility-based, faster launch manner that you find with infrastructure on the AWS platform. So we're here at aws.amazon.com. We're going to go to Products, down to AWS Marketplace, and find ourselves at the Marketplace homepage. And you can just go ahead and type Matillion into the box up there. Or in fact, at the moment, we're lucky to be a featured product on the homepage. And you can click the link, and from there launch the product. The nice thing about this is it's going to launch as an AMI straight into your AWS VPC. So just like any other workload, an EC2 instance or whatever, it's going to sit there in your EC2 console. You can choose an instance size here, and you're going to know at advance of time how much it's going to cost you to run. And there is both a launch guide, which I recommend if you're going to spin this up after the webinar that you take a look at, and some guidance on choosing the appropriate instance size. So this allows you to get the product launched very quickly and simply. It also helps to security and to performance. So in the data industry, many very good products are SaaS-based. And that's great for simplicity, but it also means that the data has to leave your systems, go outside of AWS, be processed on the SaaS platform, and then put back in afterwards. And that has impact to performance and also, of course, to security. So through AWS Marketplace and products like Matillion, you're launching the AMI directly into your VPC, taking away those performance and security issues. So we hit the big yellow button, choosing into the AWS region we wish, and about 5 minutes later, you would have a Matillion instance stood up. You'll click on that, log in, and you will arrive at this screen. And welcome to Matillion ETL. Now actually the screen that you will start off on is the Create Project team. And you're going to go ahead and specify a project group and a project name. And if you followed those instructions on the how to launch the product correctly, you should find that any AWS clusters you already have set up are available in the drop-down. You can click on one of those and just go right ahead and connect to it. The product natively understands what AWS is and what Redshift is, and so all the way through you'll see that we leverage that to make life easy and improve your productivity as a data professional. Now I'm already connected up to a Redshift cluster and I have some projects pre-built. I'm going to go to my recent jobs and open up one of those, and for the first time we now see what the tool looks like on a day-to-day basis. Here in the middle we have our canvas where we build out jobs, and we have the different jobs that we've built in this particular project available in this Explorer on the left-hand side. Up here it says default, and that's the version control. We're in the default branch of this project at the moment. If we have time, we'll get to that later. And down on the left-hand side, we have our component palette. Right now, we're looking at a transformation job, and we have components to do with transformation. Down in the bottom left, we have our different environments, and these are different Redshift clusters and sets of environment variables and other configurations that pertain to, in this case, a dev environment, a live environment, and a sandbox, and we're working over the dev environment. If we drill into that, you'll see we can see all the different schemas we have within that dev environment, and we could drill into that as we wish. Down at the bottom, a multifunction area, which you'll see how it works in a moment. And we also have some monitoring and notices and all that sort of good stuff. It's important to mention that hopefully you see already, this is quite a high fidelity interface, but it's all delivered by the web browser. So normally you get one or the other. You get high fidelity but client install heavyweight tool, but you get browser based but lots of screens and lots of server-side refreshes. And within Matillion ETL we use WebSockets technology to provide a high quality user experience but all delivered through the web browser. So let's go ahead now and create a transformation job. And a transformation job in Matillion ETL is where we do the work of joining together and transforming data. And for Ryan's team at GE, this is where they spend most of their time. We're going to call this job Flights for Webinar. And the reason for that is I have some airline flight data that we're going to use as our sample data set. Now, in Ryan's case, he is using a CDC product to replicate his SAP source data into Redshift staging tables. So the data is on Redshift in a normalized, untransformed status already, and the job of the ETL tool is to take that normalized data that's not yet been joined together and have business value added to it and turn it into analytics-ready data ready for business users to point Tableau at. So that's exactly what we're going to do here in our example. But then I'm going to show you the other half of Matillion, which allows you to easily load data onto Redshift should you not be in a position where it's there already. So our data in this part of the demo has made it to Redshift, and we need to read it into our job. I'm going to take a table input component here, and I'm going to choose the table name. Now I have some tables already on my Redshift cluster, and I'm going to choose one called raw flights. Press OK, and we're going to select some columns. So this is all working interactively off the Redshift cluster that we're pointing out. This is a live demo. It's all real. We're going to press OK, and I just want you to keep an eye on the color of the border of this component. It's gone from amber and now to green. And what was happening there is that component was validating in real time against the underlying Redshift cluster. The reason for this is Matillion is actually an ELT tool. We call it Matillion ETL because we think that's what people are Googling and looking for and expecting to use. But actually it's an ELT tool. We are pushing down the transformations onto the Redshift cluster. That has some benefits in terms of speed, also in terms of simplicity of scaling to make our software go faster. You don't scale Matillion, you scale Redshift. And as Brandon said, that's a few clicks of a job to do. But it also means that we're permanently connected to the data. So we can, having connected to this table now, go to our sample tab, and we can immediately do a row count. You can see we have 123 million rows there, and we can retrieve the first few of those rows. I've chosen 50, and you can see we have some airline flights data going back all the way to 1988, and we have the dates and times and delays and flight numbers and tail numbers on there. Now, I happen to know I've got this data going back to 1988, but I don't want all of that data for my analysts using Tableau downstream. So I'm going to go to the Transform menu now. I'm going to choose a filter component, drag that onto the palette. Let's connect those two things together. Because I'm a neat and tidy developer, I'm just going to give this a nice title. So I'm going to call it Flights Post 2000. And this is a filter component, so I just need to set up a simple filter which takes the input from the previous component. We're going to go is greater than or equal to the year 2000. Press OK. Once again, our component border went amber and then green. And if we now go to the sample tab, do a row count, we now have only 60 million rows. And if we retrieve those, we should find the entries are all after the year 2000. So we're working live over the Redshift cluster. And actually what each one of these components is doing is building a logical view which Redshift understands and then can interpret into a, albeit quite simple at the moment, execution plan, one big efficient query at the end. So that's how the product works, and that scales really nicely to very complex jobs and to very large data volumes. Let's bring some more data on now. So I'm going to take a table input component, and I'm going to bring on a second table, this time of planes. And this is exactly the sort of thing that Ryan and his team at GE Water have been doing all the time. In their case, taking commercial data from SAP, perhaps a purchase order header and connecting it to purchase order lines and the product codes on those lines, connecting to a product master file and the price connecting to a currency exchange rate file, all to come up with a denormalized flat fact table ready to point Tableau in their case at. And that's exactly what we're doing here. So I'm now going to bring on some planes. I'm just going to take all the columns for this particular table. It's a smaller table. Our component goes green. Let's take a look at that data. And we should find now we've got some airliner tail numbers, and it's telling us the manufacturer of those airliners and the type of plane and when they were built. Now I have a tail number on my flights data as well, so of course I want to join those together. I have various types of joins available. I'm just going to take a normal join, and we will wire these two components to it. Once again, I'll just give it a nice name for labeling purposes. And Brian mentioned that the tool itself is a good way of sharing with business users what is happening to their data. What are the steps we go through to go from raw source data through to analytics ready data. And because of this kind of nice graphical interface, you can take them on that journey with you. If we have time in a minute, I'm going to show you how you can do that in real time using the collaboration feature. But we're going to call this Flights with Planes and document as we go along. We're going to choose our main table as being the Flights Post 2000 component coming in here. And we're going to choose, or we'll just alias that to the word flights. And we'll choose our join table. You can join multiple tables in at once. You can even join things to themselves. But we want to join in the planes. Let's alias that to planes, and we'll call it an inner join. Press OK. And the final thing we need, as our border is still red, is a join expression, of course. Now here, this being a demonstration, my life is simple. I'm going to choose where the flight's tail number equals the plane's tail number, and that I happen to know that join is going to work great. But in real life, of course, life's not always that simple. So maybe we'd like to do some string manipulation or concatenation. Maybe we need to do a case statement to say if the code is this, then treat it like this, elsewise taste it like this. Maybe I need to pick some stuff out of a JSON array and use that as my key. We can do all of that inside of the tool. And what we're doing here is using underlying Redshift functions. You can even call your own scalar UDFs and leverage those in various points of the tool. Let's hit OK on that now. Once again, our border goes amber and then green, and we can sample the data and see how many rows we're left with, and then retrieve, and we should find that we have now got planes, flights, and they've got nicely embellished planes on the end. So you can see how you can build out these jobs. I've got here's one I made earlier. This is exactly the same job. I've just taken a bit of time on it. I've embellished on some notation here. I've pulled in not just the planes but also the airports, and I've done a calculation on this particular job using the calculate component down on the menu here. You'll find components for pretty much everything you're likely to want to do in data preparation or creation of a data warehouse. If you ever want to punch outside of that within transformation, you can put in your own SQL, but most of the components are there, and we're using the example today of a calculate component. So we've set up a couple of new fields in here, one called long delay ratio and one called long delay flag. And what we do here is we work out the total delay by adding together the arrival part of the delay and the departure part of the delay. We then divide that by the time of the flight, and basically what we're saying is, well, hey, if the delay was an hour and the flight was only an hour and a half, that's a long delay relatively. So let's pass that down. If that long delay is greater than 20%, let's set a flag to say true. And in this way, adding value to our data. This is quite a simple example, of course, but it's the sort of thing that the team at GE Water and the other Matillion customers do all the time as they add in value to the business data, working out business metrics that rather than allow the end user to calculate those themselves every time and risk getting wrong or different or create work, we calculate it once in the data warehouse and then they just all access it. So this is very representative of the work that the guys at GE are doing using Redshift and the Matillion tool. And if we have a look at the data here, again, just sampling live, we'll find that that ratio has been added in, and we have the overall ratio on whether, in fact, it was long or short. So we can build out the job like this, and once we're happy with the job, we could perhaps label it up. So I'm just going to put in a note that says, get rid of the older flights. And we could pop that on there. Now, this is useful, annotating your jobs in this way, because one of the nice features that we have within Matillion ETL is that we can share these jobs with other people in real time. So what I'm going to do now is just get a second tab going. And what I'm going to do is pretend to just chat link this job across to my colleague who may be working on the other side of the world. This is very relevant to the GE example because actually in that case there was the team working at Ryan's end at GE in North America, but also a team working in Asia, and in fact some consultants from Matillion helping with the project in the early days as well. And we were all able to share the jobs in this way, and you can see if I move something on the right, it moves on the left, and if I move it back on the left, it moves in the right. We launch a new version of Matillion ETL about every 6 weeks. The next one is due out on Sunday, so in 2 days' time. And in that one, there will be a collaboration presence, very similar to Google Docs, where you can see who else is in the job and collaborate with them in that way. So we've built our simple job. We now want to instantiate this out to a finished fact table ready to point Tableau at. So I'm going to use a rewrite table component to do that. This will take the contents of the flow, and we'll just call this create fact table. And we can choose the schema, the target table name. We'll call this F flights webinar. This would now go ahead and create that table on the Redshift cluster. We can choose a sort key. We could go for year, month, day of month, and flight number, for instance. And we could choose that is a interleaved sort key. And we can choose the distribution style on Redshift. If you're not familiar with distribution styles, go ahead and download the best practice book on Matillion.com. It will explain them. But distribution styles are super important for ensuring performance on Redshift, and you can control that here inside the tool. We'll take an even distribution style. So that's it. We've now built our job. We've been working over north of 100 million rows of data in real time. There's loads more functionality within this transform part of the tool, but hopefully that gives you a flavor of how you can build out jobs and do ELT on Amazon Redshift. Now, as both Ryan and myself has mentioned, GE were getting their data in its untransformed state to Redshift using their CDC layer, a product called HVR, and that's great. If you want to do that, that's fine. And of course, all their data was coming from SAP as well, so in that particular use case from a single source. If that was the case, you would go ahead in Matillion and create a very simple orchestration job to make that job that we've just built run. So let's call this Webinar Build Data Warehouse, and we'll switch to that job now. You'll see they look slightly different, a different range of components and a different color screen. And what we could do is have the world's simplest Matillion orchestration job. There's our job flights for webinar that we've just built. We would drag that on there like so. We would wire that together. And if we were now to run that job, choosing the environment we want to run it in, that would work just fine. And actually, we could go up to our project menu and schedule that job. So we'll call this auto build DWH every hour. And we could say, okay, we'd quite like to do that in New York time zone. And we'd like that to run once an hour, please, and on every day of the month. And we're going to run that on the default version. The job we want to run is Webinar Build Data Warehouse, and the environment we want to run it against is production. And if we did that, that would run every hour. It would track the history of how well it had run, and that would be a very simple orchestration job. Of course, not everybody has their data in Redshift already. So we provide a whole range of functionality within Matillion to help it make it real easy to get your data into Redshift. Let's say those flights were held in a copy of an instance of Amazon Aurora. We could take an RDS query component here, wire that in, call it load flights. We could choose our database type from RDS as being Amazon Aurora. We could specify the RDS endpoint name, some details, and basic SQL statements. Let's all from flights. And that component there would go ahead and load that data into the target table of our choice, which in our case was called raw flights. Now we also, of course, needed a plain info table, and maybe that wasn't held in our RDS, but that was held out perhaps in an on-premise database, or maybe it's in Salesforce or out in some other system. We provide a whole range of different connectors across technologies like LDAP and OData, social networks for loading in marketing information, documents and file formats, so Excel and Google, a range of CRM systems and marketing systems, including Salesforce, Dynamics, and Google AdWords and Analytics, as well as other technologies like BigQuery and MongoDB. And then finally down here, we have some first citizen connectors to allow us to connect to things like APIs and other AWS services. So to show you what one of those could look like, we have a job here which is setting up all four of my flight-themed data sources. I have the raw plain info that we used in our job being loaded in here. We're creating an empty table to put that in, and then we're loading from RDS, in this case a MySQL RDS component. At the same time, we are loading in our airports from a REST API, we are loading in our carriers from a G Sheet, and we are loading in our flights from two sets of S3 buckets. And then we're using a flow component here, the AND component, to say, well, hey, when all four of those loads have done, now I want to run my flights job. And that's how we build out orchestration jobs in Matillion. I'm just going to quickly speak to the REST API component. This is a useful Swiss Army knife component that we have within the product. You'll see here it's using what we call a profile, the Airport REST API profile. And again, if I whiz up to the project menu, choose Manage API Profiles, Airport REST API, you can see inside here what we're doing is we're mapping a RESTful API to a set of rows and columns that we can load into Redshift. So in this way, we can load a variety of different data types quickly and easily, and then invoke our transform to build our data warehouse. Now, of course, in this sort of pipeline, not everything always goes correctly. So we have error handling and a whole load of other functionality. But I just want to take this now from being a demonstration job to a production-ready job. So let's first of all assume that everything went well. Well, we can just label the job as ending successfully by taking this green success flow to this end success. But what we might also want to do is kick off a downstream process in AWS. So maybe we want to send an SQS message onto an SQS queue to say, I've prepared my data on my fact table and I now want some other downstream system to consume it, and I'm going to send that message via SQS, and then once that's done, I'm going to end my job. With all these systems like S3 and SNS, SQS, CloudWatch, we integrate natively, so we can just go ahead and choose a queue name here, and I could do this one here and define my message and just put in it worked. We have a full variable system behind the scenes, so each of these components publishes variables about what they're up to, and we can add new ones in that put, for instance, the row count and the duration that it took, which you could then send to the downstream SNS message. Let's say not everything went right. Well, it could have gone wrong in a few different places. So maybe the load from RDS could have gone wrong, or certainly the RESTful call could have gone wrong. There might have been something wrong with that API. G-sheets, well, they've been known to be changed between ETL runs. Or maybe the transform itself went wrong. So we put in an OR component here, and if it goes wrong, we want to send an SNS message to an operator, and then we want to mark this job as having ended in failure. So hopefully by demonstrating these two types of jobs, a transformation job where in an ELT architecture we can build out transformations, visualize our data in real time, and create analysis-ready tables ready to be consumed by downstream systems or data visualization tools. And also by showing our orchestration layer, which we can start off simply just running a job, but build up to complexity where we are managing flow, we are loading from a variety of different data sources, we are invoking our messages, we are interacting with other AWS services, and we're handling alerting and error handling and all those other important things in a production scenario. I should also mention that we can put in scripts such as Python and Bash scripts to interact with the API and other services. We can do SQL at this level as well as maintain over our Redshift cluster. We have transaction control, a quite sophisticated iteration layer, really everything you need to be successful in building out a data pipeline on Redshift quickly and easily. And then finally we saw features like the API profile mapping, version control, collaboration, and scheduling, all of which give you the environment to succeed when you're building your first Redshift project. Okay, if we can switch back, please, to the deck, we'll just take some next steps and then answer some questions. So in terms of next steps, there's a few things you can do after this webinar if you are interested in learning more. First of all, by the AWS Marketplace, you can stand up a free 14-day trial of Matillion. It's a full-featured product with everything in there you've seen. And if you need any help with that, you can reach out to us. We provide full and comprehensive support during your free trial period. And there's lots of content on the support portal and in the website. There's a demo similar to what you've seen today on our YouTube channel, as well as a full tutorial about how to stand up from a blank AWS account, first a Redshift cluster and then Matillion ETL, and connect them together. And then there's a whole load of tutorials and case studies telling you about how to use the tool and some successes that other Matillion customers have had. You can try Amazon Redshift for free. For those of you that have not experienced Redshift yet, go along to aws.amazon.com/Redshift. You can get 750 free DC1 large hours per month for 2 months. That's plenty to do a really solid POC over some decent data volumes. It was a 1 DC1 node cluster that I was running my demo from today. Finally, at redshiftssupport.matillion.com, you'll find comprehensive support, documentation, and tutorials, and you can get hold of our our pre-sales team, our solution architecture team, who, should you need any help, will help you get up and running using the tool. Many thanks for your time, and we will now move to Q&A. So one question straight away we have is from Rincy Isaacs. Do you have a Salesforce connector? I wonder if that question was asked prior to me showing it, but the answer is yes, we do. We have a Salesforce connector that will also work with Force.com applications as well. So it will pick up standard Salesforce components, and it will also pick up custom Salesforce components. And there's a kind of a query language that you can use to appropriately filter and stage that inbound information. Thanks for the question. Another question from Christopher Ramstrom. How are the Matillion job transforms versioned? So sitting behind Matillion ETL, there is a document store database, and actually we every single click, every single drag and drop is stored inside of the document database. It's a MongoDB database. And so at a basic level, the jobs are held in that document format, and that provides a real nice set of features, things like server-side undo, so you can come back to the tool hours, days, or months later, hit undo, and it will still remember the last step that you took. Now, what we do in version control is simply version those documents into a branch, and you can create new versions, you can lock them, you can decide which version is run inside the scheduler, and also whenever you make API calls into Matillion, and we have both a REST API and also an SQS API allowing you to invoke jobs externally and do various other things, you specify the version. A final thing to mention is each job and other configuration is stored as JSON, and the JSON can be imported and exported from the product via a menu click or via the API. And that means that you can, in a DevOps style environment, for instance, easily integrate Matillion with a DevOps process, taking our jobs and storing them in your GitHub repository and automatically promoting jobs through dev, test, and live based on your scripts that do that. I hope that answers the question, Christopher.
Yeah, I'll take a real quick shot at a couple of questions here. There's some Redshift questions. One question was for nodes residing in a VPC, is there an additional cost for running nodes inside of your VPC? And the answer is no. Redshift basically costs the same whether you're running it in kind of classic mode or running it in a VPC. I will say, though, our recommendation is if you have the option to run it in a VPC, then you absolutely should, because you definitely have additional configuration options, and you can make the network configuration much more custom and much more secure by taking advantage of all the things that the VPC lets you do.
We have a question from Mohammed Jamal. How well does Matillion work with data sources that are flat files being loaded into Redshift? So yeah, great question, Mohammed. So it works real well. Flat files sat on S3. We have an S3 load component. Now today, the only slight hassle with that is in order to have somewhere to put that flat file, and that can be CSV, it can be delimited, it can be Avro, it can be JSON, but you need to define a Redshift table to put that data into, and we have a create table component for that. Now in the next version of Matillion, which ships on Sunday, so if you don't start your free trial until Monday, you will experience this straight away, but that will be drag and drop, where it will suggest and infer a schema for your flat file and automatically create and optimize the Redshift table for you. So that's a small improvement we've made. But yeah, in general, flat file sources in either CSV or delimited or JSON or Avro via S3 work extremely well. Just one final point, we do also provide components called S3 put and S3 get, and what these are for is getting that flat data into S3 in the first place if it's not there already. And so basically that will allow you to pull data from, for instance, an FTP, SFTP, HTTP or various other formats, put it in S3 and then load it into Redshift, and actually the other way around as well. You can take it from Redshift down to S3 and then send it out to a file share or to an FTP location. Thanks for the question.
There's a question here about do you have a connector to Dynamo into S3? basically, can we load data from Dynamo and or S3 and build some jobs? And so to answer that question, Redshift has default support for both Dynamo and S3 via the copy command. So if you were even just using Redshift directly, you could absolutely load data from Dynamo and S3, and Matillion supports that as well.
Yeah, Brandon, that's right. And on those first citizen connectors like Dynamo S3, really all the Matillion component is doing is just wrapping some value in terms of putting it into the overall orchestration and then putting like the component monitoring and things in there. But you're absolutely right. We always feel it's better within the tool to leverage those underlying commands. And in terms of S3, when you drag a S3 load component into a Matillion orchestration job, that is invoking a normal copy command and passing in all the parameters, and same for Dynamo. So a question from Mark Chance, do all jobs run on the same web server or are there multiple EC2 instances created? So Mark, the answer to that is that it is Matillion is choreographing the behind-the-scenes work that Redshift and AWS is doing. So the Matillion instance itself doesn't sweat that much. There are certain jobs that can make it work pretty hard. Some of the data load job types that we do, but for a lot of the time, Matillion is kind of like the conductor stood in front of the orchestra that is Redshift and AWS. With that in mind, typically customers will run one EC2 instance, although the orchestration jobs themselves are multi-threaded, and that means in that job I showed you that have 4 flows going through it, depending on whether you were running our medium instance with 2 cores, 2 of those would run concurrently, large instances, all 4 of those, and an extra large you could run 8. There is some advanced stuff you can do around clustering for high availability and things like that, but in general, the jobs do run on the same EC2 instance, and you scale by scaling Redshift. There's a question, can you run vacuum analyze after loading your tables? Yes, you can. There are components for vacuum and analyze. You can just put that straight into your orchestration. It's like 1 or 2 clicks. And there's a question from Divya Alati. How do you insert update from staging to data warehouse using Matillion? So there's a few strategies available. There is an update component, and that can do a delete replace strategy or an upsert strategy with a primary key. With that, you can do pretty elegant and sophisticated incremental loads, both on the loading in from the source data and on the upsert into the fact or dimension table. There's a couple of great examples of that on our YouTube channel. In fact, if you look out for the YouTube channel by our product manager, David Langton, on incremental loads, it will show you that particular example working exactly as you've asked. There's a question from Tasif Chahan. Can we use Lambda to load data in real time to Matillion? So if I'm understanding your question correctly, the answer to that is yes. Let's say you had an object arriving in an S3 bucket, and that S3 bucket has a Lambda event tied to it that fires on new object creation. Well, in that Lambda event, you could choose a couple of different ways. The way I'd probably recommend is that you have the Lambda event create an SQS message, and you can subscribe the Matillion ETL instance or project to an SQS queue. It has a listen queue, a success queue, and a fail queue. You subscribe the project to the listen queue, and it will then start monitoring any inbound messages on that SQS queue. The message format you can see on redshiftssupport.matillion.com. It's a JSON message which simply passes in the name of the job, the version number, the environment you want the job to execute on, and any variables that you'd like to pass into the job. So let's say our object arrives on S3. You might want to pass in the name of the object to the Matillion orchestration job. Lambda triggers on creation of the object, drops the message onto SQS. Matillion reads it off SQS instantly, invokes its orchestration job, passing in the name of that object that's been created, and loads the data through S3. And so, as you correctly predict, you can use exactly that strategy to deliver a real-time or near real-time upsert using Matillion and those other technologies. So there's a question from Christopher. The question is, if we have a large number of source tables that make up transactions, would this be a good use case? In essence, do joins actually happen within Matillion, or are they passed down to Redshift? So absolutely, it's a good use case. And if I was to show you some of the jobs on the GE reference that we are here talking about today, these things have hundreds of joins in. And the reason for that is because the data is coming from multiple instances of SAP, and those instances, for a starter, in different business units of GE Water, in different countries and different business rules, but also SAP itself is made up of literally tens of thousands of files, and what we're doing here is denormalizing those together. So yeah, you can build really complex joins, and those joins are pushed down to the Redshift cluster. Now, there are some optimizations you can make in the most extravagant jobs. So if you are dealing with high cardinality complex joins over large data sets, then you can, using the transformation job, for instance, maybe do the first few of those joins, and then you can instantiate that data down to a Redshift table using a table output component. You would set the distribution key of that output component to then help the join in the next transform job that you want to create. So in that way, there are a couple of usability tricks that certainly we'd be happy to share with you. But the straight answer to your question, does it push down the joins to Redshift? Yes. And is it suitable for a large number of source tables? Absolutely. That's kind of what it's built for. Great question. Thank you.
I think I'll take a shot at the very last question here because we're kind of running out of some time. But the question is, would you recommend starting with a 2-node cluster versus a single-node Redshift cluster if at some point eventually we'll have to scale our cluster? And so actually I would encourage you if you're not sure quite how to scale your cluster initially, that you look at, we have actually a documentation page about choosing the right type of node and determining the number of nodes. And this is super use case dependent, but we do try to give you some guidance based on, what are your requirements for how much data do you have to store across the cluster? Do you have more priority on CPU performance versus data storage, for example? And then the beauty of this, of course, is that even if you choose to start with a single node cluster, you can resize your cluster in the future, and there's no limit to how many times you can do that. So the idea is kind of get started with it, after kind of considering what different nodes might meet your use case, and if you find out that you need more nodes, go ahead and size it up. And then you wait a couple of minutes, and then you have a newly expanded Redshift cluster. So that would be our suggested approach.
So guys, that takes us to the top of the hour. Many thanks indeed to everyone that attended, and I'll hand back to Jerry to close the call.
All right, well, thank you, Matthew. And so again, we'd like to thank everybody for joining today. We do appreciate your time. I'd like to thank our presenters and panelists for all the great content and the time today. This time you can disconnect from the session. Thanks for attending. Have a great day.